Hello everyone, this is a special screencast. It's a behind the scenes for some updates that have recently been made to the Web Velocity beta. For people who are in the beta program, this is relevant. For people who aren't in the beta program, this still might be relevant. Could be interesting for you. Maybe you want to get involved in the beta program. If that's so, get in contact with James Robertson and he can get you an NDA and get you all set up. And then you can help us debug this thing and get it into production. So these changes that I'm about to show you are not actually integrated yet. They should be integrated very soon. Hopefully, they need to pass the stringent review tests. So what you're about to see is not available just yet, though by the time you watch this, maybe it will be. My hope is that it'll be in the next build, and as of the 7th of July, so theoretically it could be available in 7 days or less. Anyway, enough of that. This screencast is first going to show you what's changed, and then what's been updated, and then we're going to go behind the scenes and look at how some of this is done. And at that point, if you're not interested in the technical details, you can just tune out or hit stop. But if you are interested in the technical details, then stay with us. Getting started, let's have a look at what we've done with code editing. So I'll pick on my favorite little application here, and we'll go down to the post class, source code. First things first, if we want to edit a method, we can just create a new method. Actually, we won't put it in there. We'll make a public protocol. Public. So in public, we can just create a new method. Call this one my method. And we'll return a string. Okay, so what we see here right now is if we hit Control S or Apple S or right click, show you the right click menu, save, it will now indicate that the save has happened with the flashing green there. If on the other hand we have an error on the page, and we can hover over the error and see what that error is, and we try to hit save, it flashes red to indicate that that just did not work. The same deal if you try to navigate off this stuff, you get prompted whether you want to save or cancel or what. In this case we'll save, and we'll pick cancel. So we threw that method away, that's gone now. Here's my method that we made. If we keep making new methods, we'll just return 6, then a new method thing keeps popping up and allowing us to keep building methods more and more and more. So on and so forth. And that means that we're doing less round trips to the server to create code, and the same with delete. If we want to get rid of a method, it just takes it away and does a very minimal call to the server to do that. And that's really important because this is the programming environment, and if the programming environment runs slowly, then you're not going to be productive, you're going to get frustrated, and it's just not going to be a very nice environment to work in. So this was really important to get right, and hopefully we've fixed it now so that it's nice and fast. So much so that it's now possible to scale to an object that is ridiculously big, like object. So we click on object, and just a couple of seconds of wait, and the browser realizes it has a lot of work to do. Now, the communications from the server are pretty quick, but putting this much content onto the page is a big job for any browser, and Firefox is one of the best. Safari doesn't do too bad a job. IE takes a while, but that's IE for you, so that's kind of to be expected. But once it's got this stuff up, you don't have to throw it away. You're in this dynamic environment that updates things as it goes. As we're saying, create new methods on the fly, and we're away. So that's really nice scalability there. It's good, proof that we're doing the right sort of thing here. Okay, let's move on to some tests, and we've got an application here that's got some tests in it. Web velocity testing, I think, is what I want to play with. If we have a look at the tests tab here, we see all the tests for the different classes, and we can run them all. Click run all, and in a second it'll tell us that everything's passed, because hopefully I haven't broken anything. Here, there we go. Yes, my CPU meter has gone to the roof doing this recording, because it's in a reasonably high resolution. Okay, so we run the tests run. They don't normally take that long. To show you what I mean by that, if we come in here and we can cherry pick a method, and we can right click here and go run, and we can't really even tell that it ran, so let's put an error in there. Oh, there's a nice little feature I forgot to show you. Let's just cancel that edit. So here we hit enter. What it figures out is to auto tab for us. See, we're already here. Auto tab. Takes a little bit of getting used to. Save that away. Now if we hit run on this method, it will tell us that it did not work. Or even better, we get an error down here. So that's something that I'll have to fix up later. We'll ignore that for now. So it was test paths we were modifying, right? Run. Okay, so there's a failure. To be expected. This hasn't gone through the testing like I said at the beginning. So these sorts of things are going to happen. So moving on. Now if we create a new test, and we'll just leave it called test XXX. We'll put in the basic self-true assertion here. Save that away, and it knows that the test hasn't run. So this is kind of the opposite, where we're not breaking a test, we're running the test. I think perhaps we broke the page. There we go. So yes, that's what we did. We broke the page. Okay, so let's edit this again and remove that from here. So now our test should actually pass if we run it. There we go. Okay, so that's working the way I expected it to work, but obviously I've got an issue there to fix up. Okay, so that's the test. So small updates there. It doesn't have to update the entire page, which means you can be editing in the middle of it, right? You can have 2 or 3 of these editors open at once and haven't even saved it, and then running tests as you go. Same with general code editing. You can have lots and lots of methods open and save them all when you're finished, and which is a pretty good classical way of doing development. Breakpoints. Let's put a breakpoint in. So adding breakpoints is as easy as going breakpoint. Puts a little stop sign in there for us. If we have a look at the breakpoints page here, it shows us the breakpoint that we've got, test paths here, and we can say remove all the breakpoints. So do that and it's gone. Now I wanted to go into the debugger, and in fact this is a really good place to do it from because we've got the debugger tests here. Here we have a debugger thing called halt, broken debug component. Have a look at its code. Render content on says do stuff. Do stuff says in a block do more stuff. In the block just runs the block value, and do more stuff has a halt in it. So the idea here is that we're in a complex stack. We're inside a block context, and we're in the middle of a seaside rendering, and we've got a resumable exception. So you should be able to hit resume in the debugger and see this come up correctly. So let's see what the debugger now looks like. If we click on halt, we immediately come up on the halt. Okay, so the debugger looks like it did before. However, it is immensely faster. If we click around the stack, you can actually see it responding as if it were a real GUI, right? In fact, to be honest, and don't tell anyone, I've actually been finding this debugger is slightly easier to use than the VisualWorks regular GUI debugger. But it's missing one important feature, which is the ability to do random ad hoc scripting. And I hope to add that at some point in the future so that it is as good as the GUI debugger. Okay, so we're clicking around. It's pretty darn quick. And if we have a look over here, we've got an inspector. And the first thing here is self. And we can even go and inspect the class, but we can look at the decorator, which is a value holder, so on and so forth. If we have a look at the class, we can have a look at the subclasses of WI component, and it's got none. There you go, nil. And it's got a name. We'd probably change the name, but that would be ridiculous. So coming back from self, we can look at HTML, which is our renderer. So we know it's a WA render canvas. It's got some callbacks. It's got no current brush. It's got a context. And we've got our session. Our session has some continuations on it. Timeout, cookies are enabled. We've got our current requests. Let's have a look at the current request. It's a native request object here. It was a get. It's for this URL. And there were some headers. Let's have a look at the headers. Accepted, referrer, host, user agent. There were some fields, which is a dictionary. It's an empty dictionary. There we go. And cookies. So again, no cookies for this request. So there you go. The inspector is really quite powerful. It lets you explore as far as you want to go, and it's a lot more efficient than it was before. So it can show lots and lots of data if there is lots and lots of data to be seen. Maybe we can get an example of that here. This is the organization of the methods in WA render canvas, and expanding that to the elements array pops up very quickly with lots and lots of data. Okay, so we also see down here that we highlight what's actually currently active in the stack. So if we click around here, we see this one's highlighted at the end, the method's finished. That's on the halt. That's on the do more stuff. That's on the value. That's on the in block self do more stuff, and it's on the do more stuff, and we can go on and on and on and see that in action. But what I want to show you now is how we can rename stuff. So if we come back to this method, and this is what we're about to call, let's do two things. First of all, we'll remove the halt, and we'll change the name of the method, like so. If we hit save now, it will drop the stack back to the renamed method and continue running. I'll let you just catch your breath for a moment. We just renamed the method while it was running, and it dropped back to it and will continue working. If we hit resume now, we get the page as it was intended. Halt is resumable, you resumed it, it worked. So let's go and put that halt back in there, because there's more to this than meets the eye. At this point, we're going to shift gears. We're now going to go technical. If you're interested in how all this stuff works, stay tuned. If not, you may as well hit stop, because now we're going to look at the underlying architecture of some of this stuff. Do more stuff renamed, self do more stuff. This example will no longer work because the method doesn't exist. Since I'm trying to demo this stuff, we'll put it back in. We'll put a halt there and rename this thing as do more stuff. Save that, and we're done. That's now renamed. Okay, let's bring the debugger back up. Now, I was talking about speed before. How do we make it run so quickly? Well, the answer is in the communications. Let's clear this and see what happens when we click on do stuff. A message was sent to the server, and inside it was a JSON object. And the JSON object has a selector and arguments, which is surprisingly similar to the message object in Smalltalk, which has selector and arguments. Why? Because we are sending a message to the server. Here we send the message object to the server will then check to see if it can send that message. Server sets selected context with an argument of 4. And in response, the server gave us back an object. It said, this is how the inspector looks now. These are the breakpoints we have on the page. This is the current frame we're on the stack. And this is our current code. And we should highlight that code from 21 to 53. So the reason it's so quick is because it's sending so little data back and forth. And each one of these buttons here does the same sort of thing. If we step into the halt, then we see the post was service send. So we're sending that message to step into the halt, which in actual fact puts us up here. And that's basically what's going on here. We've got a large bandwidth of communication by having multiple ways for the client to talk back to the server. So how does this look in the Smalltalk code, and what's really going on here? For this, we need to bring up the standard refactoring browser and take a look. I'll just terminate this thing in the background here. We don't need that anymore. Okay, so Seaside development. We've changed some stuff. We can undo that later. It won't matter. And we go into Seaside components, and in here is a package called Seaside Gadgets. And Seaside Gadgets is where most of these interactive widgets come from. You can use them in your own applications if you want. You can use Scriptaculous if you want. You can just use plain HTML elements and form fields if you want. Seaside is very flexible, lets you decide for yourself how you're going to do that. But Communication Gadget is the one that we care about right now. Communication Gadget gives us a standard way to send messages from JavaScript. We just say send selector. And through the magic of JavaScript, we can pull extra arguments. So if you go send selector with some arguments, it'll turn that into a message object, which we then encode with JSON or JSON. I'm not sure how people meant to say that. And that's then sent to the server, and the response comes back. We de-JSON it. So we decode it and return that as our result. So that's a proper RPC sort of mechanism right there. And if there's an exception, we catch the error and we can throw an error for that. And then the JavaScript code can catch those errors if it wants to as well. And this gives us a lot of flexibility, but not enough. It's not enough. That's definitely not enough. If we go down to Test Communication Gadget, here this is a gadget that has some JavaScript actions on it. It's got this one here, alert send example. It pops up a dialog with an alert, this.send example. However, there's no JavaScript method here called send example. There is, however, a Smalltalk method, send example, And we've got a pragma in it called function, which basically means we want this to be a JavaScript function as well as a Smalltalk method. And it will actually create a method that looks like this. I'll just write it for you. It will make a method like that on the client side for you to call, so you can then just send the Smalltalk method as if you were calling a JavaScript method, and it will do the communications to the server for you and you get the result back. So in this case, we return a timestamp printed as a string, and the JavaScript code gets that string back and pops it up in an alert. So why don't we see this in action? Let's go to that page, which should be in CISO gadget testing. And we have our entry points here. We want the communication gadgets. The first one, send example that pops up an alert with an object from the server. So in this case, we just grab the timestamp from the server. How about an example that replaces its own content? So this is the classic change my content. In that case, content updated. Refresh content allows the server to define which IDs on the page it wants to update. So we can actually update multiple areas of the screen at once. Dialog example pops up the content inside a dialog box, which comes from Mutual's Mocha. That's very cool. And async, we really need to see the transcript to see what's going on there, just sends the message and doesn't expect to get a response. So how does the debugger run so fast? Well, the debugger is a gadget, and so is the inspector, and it has lots of actions. Service continue, service first loop, method changed, re-enter block, method send, set selected context. And all we're doing is saying, yeah, this is stuff that we can call, which makes it really easy from the JavaScript side to do things like, okay, put an image on the page, and when we click on it, action step into. Action step into just goes, update our state after sending service send to the server. Service send to the server is going to do service update. Service update is going to produce a dictionary of things to update. Then the client side again does its update method and just changes all the widgets that are on the page, and that's it. That's the whole story. That's how we can blend Smalltalk and JavaScript together so easily. They sit side by side, and JavaScript can call Smalltalk. Okay, so that's the crux of the thing, the main changes, the thrust of the main changes, and the new speed of the environment. And like I said, hopefully this will be in a WV build shortly. Thanks. Bye.